Hi, I'm Don DeTore, the managing editor of Rubber and Plastics News. I'm with the Harold Herzlich Award winner.
Hi, I'm Bernhard Blümich. I'm a professor at the university in Aachen, and I'm here to speak to Don.
Dr. Blümich, tell me about your invention, the mouse.
Well, the mouse is actually it's nothing what you would think it is. It's an acronym for Mobile Universal Surface Explorer. It's related to magnetic resonance imaging. It's a little device that can be brought to a car tire, and then it can analyze the car tire and, for instance, look at cross-link density at various positions within the car tire.
Tell me how long you've been working on the project and some of the advantages that it brings to the tire manufacturers.
Well, the project actually turned out to be a playful enterprise. We wanted to make things simple, what we call magnetic resonance imaging. And that was in 1993 when we had the idea, and the first functioning device we had in 1996. And we learned that it basically measures the information of 1 pixel of a magnetic resonance image. And imaging MRI works well in soft matter. So we thought, well, soft matter outside medicine would be rubber. And immediately we looked where's the biggest use of rubber, and that's tires. And this is how we ended up with the tire industry, which very quickly caught interest. And it was actually at a racetrack south of Aachen, so-called Nürburgring, where we did a test, first measuring tires with the NMR mouse, nuclear magnetic resonance NMR mouse. And then the test pilots tested the tires, and it turned out that both data correlated, and that caught the attention of the industry.
Explain to me the size of the device, as well as the advantages of actually running the test on the tire as it sits on the vehicle.
Well, the device is maybe this big, at least it used to be in those days. Now we have smaller ones, we have bigger ones. And one can measure a whole depth profile through the tire. That is, you can see the different layers of the tire. You can learn about the crosslink density of the different layers. You can learn about optimizing the vulcanization process. You learn about, let's say, even temperature gradients when the tire is warm, if you have the profile when it's cold and when it's warm. And you learn about aging. So usually that's done in the factory, in process product control, but you can also do it on the racetrack if you want, and maybe that's an interesting option to look at Formula One, for example, to select the right tires for the right type of weather and to optimize what tire to take.
And we talked about some other applications that the mouse might be used in. Can you briefly share that with some of our...
Well, the most fascinating one is actually in analyzing, as they say, objects of cultural heritage. And that goes from master paintings to master violins to frescoes in ancient buildings or excavation sites. We looked, for example, at the painted walls of the villa of the son-in-law of Julius Caesar in Herculaneum, which is an excavation site near Mount Vesuvius next to Naples in Italy.